Dr. John, your physics and math professor. Welcome to trigonometry. We're going to do a couple of identities here. Here we have a fairly complicated one where both sides are complicated. Often you'll take the easier side and move it over to the harder side. But here this one has sine 2 theta over 1 minus cos 2 theta, a couple of double angles. Here we have cosecant 2 theta, a double angle, and a reciprocal of the sine. And here we have tangent, your straight up tangent. So we're going to have to maybe work with both sides. If you can work on both sides here and get this side and this side equal to the same thing, then you could go all the way around, because all these things are reversible. You could go one way all the way, or the other way all the way, and you could get the answer proved that way. So if you can take both sides, get them to the same thing, that's fine too. We're going to try to do that here, left side and right side. This here would be the left-hand side, and this would be the right-hand side. I'll try to put a dashed line between them and do a lot of my work over here. So we have a couple of these identities. We'll have the sine identity, and this is really the sine identity as well, but it's in the basement. And here's the cosine identity. I'll just write out what those are here because we're going to use them a couple of times. So there's the sine 2x is 2 sine x cos x, and the cos 2x, I have these on a sheet that you can download. You can do this one with the sine, the cosine, or a mixture of the two. I'm just going to do this one with the 1 minus the sine, because that way everything sort of gets moved towards sine. Since there's a sine here and a sine there, we'll see what happens. You can always try it and then try the other way later. So that's 1 minus 2 sine squared theta. It's a complicated one, similar to this, but it's a little bit more complicated. Let's take these principles and pop them into this left-hand side here and see what we get. For the first one, it's going to be sine, so it's going to be 2 sine theta cos theta. That's just the top here, all divided by 1 minus this thing here is going to be this thing here, which is all of this. And I have to put that in a bracket here, like that, okay? So this bracket here would be the same as this bracket over here, if I want to put a bracket in there. Put a bracket in there, 1 minus. Very important to keep your brackets straight, end of bracket. Now you notice you have a 1 minus a 1. That 1 is going to disappear, which is what we were hoping for. And then a minus sign applied to this minus sign. Those two are going to cancel each other, and we're going to be left with just this without the bracket. And I'm going to erase the bracket over here. So we're going to have this term here. The 2 can cancel with this. This sign will cancel with one of those signs. We're going to be left with cosine theta over sine theta. Now we've got it into plain old sine, cosine, trig identities, trig definitions. So that's going to be helpful to us. So I'm going to take this here, the left side, and just rewrite this over here. Let's use our pink for that. So this whole thing here is going to be cosine theta over sine theta. So that's this whole left side here. All of this becomes this. There. Now we look at this side over here. I'll erase a bunch of stuff and start over here again with this. All right, we have this over here, which you could rewrite like this. 2 divided by sine 2 theta. Because this really is 1 over sine. It's the reciprocal of the sine, the cosecant function. So you would write this whole thing like this. You remember we just did this one over here. So let's plug that whole thing in there. That whole thing would be 2 sine theta cos theta. That's all of this. Now we have this canceling with this. We're left with 1 over sine theta cos theta. That's for this term right here. Minus tangent theta. Let's write that all out and see how it looks. 1 over, I've written down over here, I've rewritten this here, the right-hand side, just like this, after we've done a little bit of work on that. Now we notice here we have a denominator with a cosine and a denominator with a cosine sine. Might be helpful to get the same denominator. So let's multiply the top and the bottom here by sine. I'm just going to rewrite this here again. 1 over sine theta cos theta, that's this term here, minus I'll multiply the top and the bottom by sine. So it's going to be sine squared theta over sine theta cos theta. This term here becomes this term here. Notice now if we try to write it all with a common denominator, this is going to be sine theta. I'm going to write a giant line here, like that's here, all over sine theta cos theta. Notice here we have 1 minus sine squared. That's always a hint. Sine squared plus cos squared is equal to 1. Cos squared is equal to 1 minus sine squared. So this, all of this in the numerator here is cos squared theta. Now it looks like you can do something. Here's 1 cos, here's 1 cos. We're left with cos theta over sine theta. Is that helpful to us? Let's take a look over here. The left-hand side was cos theta over sine theta. Right-hand side, cos theta over sine theta. We've just proved this identity, which was a little bit more complex. Hope that helped. If it did, like and subscribe. I'll see you in the next video. Bye-bye.